career, fighting for your family. Some of you are fighting for your life. And I am telling you, do not quit. Do not give in. I know life can be tough. I know life can wear you down, but if you just stick it out, even if you don't get the result, you will find the character you show will be your reward. The fighting spirit you develop will be the reward, and it will serve you well for the rest of your life. Fight for what you want now, or fight against what you don't want later. You choose.
Don't you dare quit. Don't you dare settle. Don't you dare back down. Not today or any other day. When the tough moments come, never forget you are in that moment. Write your legacy. In that tough moment, you are setting the standard for your character. Do you have the character? You do.
Fight for what you want now, or fight against what you don't want later. You choose. Fight for what you want now, or fight against what you don't want later. You choose. When you come to a crossroad and run into the winner and the quitter in you, listen to the winner. When you make a commitment to yourself, you make sure you see it through. Never, ever quit.
All right, on that note, I want to once again welcome every one of us. There is a winner in each of us. There is a loser. There is a winner, there is a quitter. When you're at any point, any crossroad, the winner will talk to you, the quitter will talk to you. So my advice is for us to always listen to the winner. Another nugget I want to share with you guys is fight for what you want now. Fight for what you want now, so that you won't have to fight against what you don't want later. Fight for what you want now, so that you won't have to fight against what you don't want later. All right, thank you guys once again for coming on. I want to look at the correction to our assignment. A piece of advice I would like to give each of us is that every information that is given by the examiner, every information you have in a question should be taken as very, very important. If you look at this question, for instance, the question says, given that sine open bracket A plus B close is equal to sine A cos B plus cos A sine B, without using mathematical tables or calculator, evaluate sine 105 degrees, leaving your answer in short form. You may use 105 degrees to be 60 degrees plus 45 degrees. Now, if you look at the first statement in the question, it's telling you something. Sine A plus B bracket, sine open bracket A plus B bracket close is equal to sine A cos B plus cos A sine B. Now, that implies that if you are taking your 105 degrees to be 60 degrees and 45 degrees, your A, you'll assume your A to be 60 degrees and your B will be 45 degrees. The reason you are given this hint is because 60 degrees and 45 degrees are special angles. They are special angles that have a special trigonometric ratio. So what you just do is wherever you see A, put 60 degrees. Wherever you see B, put 45 degrees. So that you will have sine 60 degrees multiplied by cos 45 degrees plus cos 60 degrees multiplied by sine 45 degrees. Sine 105 degrees is equal to sine 60 degrees multiplied by cos 45 degrees plus cos 60 degrees multiplied by sine 45 degrees. Now, the next thing you do is to get your values of sine 60 degrees, cos 45 degrees, cos 60 degrees, and sine 45 degrees. From the table I shared with you guys the last time, sine 60 degrees is equal to root 3 over 2. Cos 45 degrees is equal to root 2 over 2. Cos 60 degrees is equal to half, 1 over 2. And sine 45 degrees is equal to root 2 over 2. So what you need to do next is to insert all these numbers into this equation so that we will have sine 105 degrees will be equal to root 3 over 2 multiplied by root 2 over 2 plus half multiplied by root 2 over 2. So if you multiply, now if you look at the first part of the equation, root 3 over 2 multiplied by root 2 over 2, you can multiply root 3 by root 2 to get your root 6. The same way you multiply the denominator, since this is multiplication, not addition or subtraction. Since it is multiplication, if you multiply the numerator, you will also multiply the denominator. So the first part will give you root 6, root 3 multiplied by root 2, that will give you root 6. Then 2 multiplied by 2, that will give you 4. So that you will have root 6 over 4 for your first part of the equation. The same way, cos 60 degrees is half, sine 45 degrees is root 3 over 2. The same way you multiply the numerator and the denominator here. So the numerator is 1 and root 2. So 1 times root 2 will give you root 2 over 2 times 2, which is 4, will give you 4. So that you will have root 6 over 4 plus root 2 over 4. Then since this is addition now, since they have a common denominator, the common denominator is 4. So since they have a common denominator, you can add the numerator. You can add the numerator so that you will have root 6 plus root 2 all over 4. You will have root 6 plus root 2 all over 4, which is our answer. Please, I would like to confirm if that makes sense to all of us. I would like to confirm if that makes sense to all of us. Is there anybody who has any question after what we just discussed now?
No, sir, no question.
It's very clear to all of us.
No, sir.
Okay. Let me give you guys a piece of advice. Let me give you guys a piece of advice. What you guys need to do is to go to your textbooks, go through your textbooks, and as many as possible, you look for questions on all that we have discussed and try to solve them. So anyone you encounter any problem, I give you a free privilege to chat me privately, and then we'll look at it together and we solve it. I hope that is fair enough. All right, so I would want us to go on to today's topic. What we are starting today, we are moving into, see, we are not just treating trigonometry for treating trigonometry's sake. There is a wide number of applications of trigonometry, and we are going to look at some of them before our sessions end. Today, we will start with angles. We'll look at the two main applications of elevation, two main applications of trigonometry. And these are angles of elevation and depression, and the other one is bearing and distances. Angles of elevation and depression, and bearing and distances. So today, we are going to start with bearing and distances. And we are going to start with bearing and distances. Sorry, we are going to start with elevation and depression. Sorry about that. We are going to start with elevation and depression. Now, from the English word elevation, I want someone to I want someone to tell me, what do you understand by the English word elevation?
What do you understand by the English word
I want someone to tell, what do you understand?
elevation?
Sorry? Bailing us out. What do you understand by elevation?
Elevation means to rise, like when something rises to a higher point.
Good, good. That's beautiful. It's at a higher point. It's at a higher point. That's the key word I'm looking for. That's good. Something is at a higher point. Something is higher than your level of sight. So what it simply means is that angle of elevation, angles of elevation, these are, I have the illustrations here by diagram, the angles of elevation and depression. We have illustration by diagram. What the person who spoke now, what he or she just spoke about now, the angle of elevation. If you look at this diagram, if we look at the two diagrams we are seeing, you can see the eye level of the observer. So the observer is viewing something at a higher height. So when you view something at a higher height, what you will have is angle of elevation. When you look at something that is at a higher height compared to your own line of sight, you will be talking about angle of elevation. So look at the way I put it. I say angle of elevation denotes the angle from the horizontal upwards. You can see the line, the word upward is underlined. Upward. So you are looking upward. So an observer's line of sight will be above. So look at, if you look at those two words, they are in sync with what the last speaker said. You are looking at something upward, or you are looking at something above. So for angles of elevation, the object you are looking at will be above your line of sight. I hope that is making sense to us. Now, what of angle of depression? In the same way, depression is opposite of elevation. Angle of depression denotes the angle from the horizontal downwards. You can see downward. You can see that word, downward, to an object. An observer's line of sight will be below the horizontal. So you look at those two words, downward and below. So that implies that the person that is looking at an object will be at a higher height. You know, for elevation, we said the person looking at the object will be at a higher height, will be at a lower height, sorry. You will be at a lower height than what you are looking at will be at a higher height. But for angle of depression, what you are, the observer will be at a higher height. And what the observer is looking at will be at a lower height, will be below this line of sight of the observer. I hope that is clear to all of us. Or do we have anybody who have any question?
Okay. No, sir.
Okay, so
No,
we
sir.
can continue.
No, sir.
All right, thank you. So I want to give us a step-by-step approach to solving problems involving angles of elevation and depression. You see, the procedure is the same. The most important thing is for you to be able to get correctly the diagram. The procedure is the same. The procedure for solving angle of elevation and angle of depression is the same. So the first thing, which is, I always tell my students, the most important thing in solving problems on angle of elevation and depression is you draw a sketch of the situation you are given. You will recall that when we were looking at trigonometry, the first step, we said we should draw a diagram. The same thing happens to angle of elevation and depression. So the first thing is you should have a picture. You should have a picture of what the diagram is talking about. And as I mentioned to you, when you have any question, every information in that question is very important. So the first step is you draw a sketch of the situation. Then you mark in all the given parameters, all the angles and all the sides you are given. You mark it out. Then you also take notes of the angle or the side that you want to find. So mark in all the given parameters and also note all the requirements, all what you are required to do. Then you use trigonometry to find the required information. Use trigonometry to find the required information. We don't need to cram these steps. I believe that by the time you solve 1, 2, or 3 questions on your own, you would have mastered the steps. So there won't be any need for you to cram the steps. Now, I want to give us a very important information. Note, all problems on angles of elevation and depression will always lead to a right angle, either a right angle triangle alone or a combination of right angle triangle and a rectangle. So we should note this. You will always have either a right angle triangle alone or a combination of right angled triangle and a rectangle. So, and you will agree with me that this underlies the importance of what we have done in the last couple of days on trigonometry, because we are going to be strictly dealing with right-angled triangles, even in questions or problems involving elevation and depression. I hope it's making sense to all of us.
Yes, sir.
Hello? I hope we are getting it there. It's making sense.
Yes, sir.
Sorry, does anybody have any question?
No.
No, sir.
Okay, so I can continue, right?
Yes, sir.
Yes, sir.
Good. So if at any point in time you have a question while I'm talking, just raise your hand. Then I will unmute you so that you can ask your question. Now, I want to also point out something for us. There are some particular features. There are some very common terms or features with angles of elevation and depression. You may need to write this down. It's not in our slide. So you will almost always come across something like a pole, P-O-L-E, a vertical pole. You may come across something like a vertical pole. You may come across something like a cliff, C-L-I-F-F. You may come across something like a tower, T-O-W-E-R. So those are some of the things you will come across in questions involving elevation and depression. What they only means, all this, if you look at all of them signify something that is vertically upward. All of them signify something that is vertically upward. And when you have something that is vertically upward, it implies that either pole or tower or cliff will make a right angle with the horizontal. So when you have an object that is vertically upwards, the implication is that that object will make a right angle, a 90 degrees with the horizontal. All right, so I want us to look at this question as an example. We're told that the angle of depression of a point Q from a vertical tower. You recall that I mentioned something, tower. From a vertical tower, 30 meters high is 40 degrees. If the foot of the tower is on the same horizontal level as Q, if the foot of the tower is on the same horizontal level as Q, find correct to 2 decimal places, PQ. Let me repeat the question again. The angle of depression of a point Q from a vertical tower, PR, 30 meters high, is 40 degrees. If the foot of the tower is on the same horizontal ground, is on the same horizontal level as Q, find correct to 2 decimal places, line PQ. Now I want to unmute you. I want to ask some questions. I want to ask a question. Now, can someone tell me what are the information we have here? What are the important information that we need to pick out from here? What and what and what do we have?
Well, the height of the vertical tower.
We have a vertical tower.
Mm.
We have given the height, right?
We have the angle of depression of point Q.
We have the, sorry, let's take it one by one. We have a vertical tower, and the vertical tower is denoted by PR. The vertical tower is denoted by PR. The height of the tower is what? What's the height of the tower? Were we given the height of the tower?
Yes, sir.
Okay, what's the height of
30 meters.
30 meters.
30 meters?
30 meters.
So we have been able to pick out one information, that there is a tower and the height of the tower is 30 meters. Also, we were told that the tower is PR. So the first thing you need to do is to draw something like a tower. You don't need to draw anything spectacular. Just draw a straight line, a vertical line, and label it PR. You can now put in brackets tower, then put the height 30 meters. Do you understand? Hello, do we understand that?
Yes, sir.
Okay. Now, they also told us that there is a point Q. Note, they said there is a point Q. And the angle of depression of this point Q from the tower is 40 degrees. Now, we're told the angle of depression. That means we are looking at the tower we are looking at point Q from the top of the tower. Is that making sense?
Yes, sir.
We are looking down. So that means point Q is down, and we are looking from the top of the tower down. So that means our angle of depression will be the angle between the horizontal level up and point Q down. Does it make sense to us?
Yes, sir.
Yes, sir.
So let me show you my diagram. The question says we should find correct to 2 decimal places, PQ. The question says we should find correct to 2 decimal places, PQ. Now, can we see my own diagram?
Yes, sir.
So can we
Yes,
all
sir.
relate with this diagram? So we can see that PR is the tower. They told us it's 30 meters high. Then they told us that P and Q are on the same horizontal level. Then they also told us that the angle of depression from R to Q is 40 degrees. So that's the 40 degrees there. So we are asked to find PQ. We are asked to find PQ. Now, I want to point out something that will be that will be of importance to us in our discussion on angle of elevation and depression and bearing. And it is called Z angles. We used to call it Z angles. It is called alternate angles. It is called alternate angles. Now, if you look at this horizontal line from R to this horizontal, that line is parallel to PQ. So when you have two lines that are parallel like that, the angles that are formed, if you draw a straight line across them, the angles that are formed inside the edges are the same. They are equal, and they are referred to as alternate angles. They are referred to as alternate
angles.
So if we look at this angle now, and if you look at this angle that they are showing us as 40 degrees, which angle will be the alternate angle to this 40 degrees in our right angle triangle? Q. That's good. Fantastic. So angle Q will be 40 degrees. Then you will need to tell your examiner, the person who is giving you the question, why you are saying that that angle is 40 degrees. So let's go through my solution. I said we're given a vertical tower PR, 30 meters. The angle of depression of Q from R is 40 degrees. Then we are required to find PQ. Yeah. So from the knowledge of parallel lines, angle PQR, that's angle Q, is equal to 40 degrees. And I gave you
Yes, ma.
alternate angles. They are alternate angles. Is that clear to us?
Yes, sir.
So if we look at the diagram now, we have, if we look at the diagram we have and the information we have, we know this angle Q and we know this side. But we want to find PQ. So we know PR, we know angle Q, we want to find PQ. So what is the trigonometric ratio that we are going to employ? So the first thing is this angle Q that we know, PR is the side that is facing it. So to this angle Q, PR is what side? Is the opposite. Then PQ is the line that is joining our angle of reference to the right angle. Joining our angle of reference to the right angle. So that means PQ will be what?
Adjacent.
Good. Good. So we have opposites and adjacent. So which trigonometric ratio connects opposites and adjacents?
Tangent.
Tangent. Good. So that implies that is what I've just explained here. Side PR is opposite to the known angle, while PQ is adjacent. Thus, the trig ratio that is applicable is tangent. So we will say and P, this should be tan PQR. It should be tan PQR. And PQR is equal to PR over PQ. Tan PR is equal to PR, which is opposite, over PQ, which is adjacent. So we know the opposite, and we know our angle PQR. So tan 40 degrees will be equal to 30 over PQ. So when you use a calculator to find tan 40, you will get 0.8391. 0.8391. So instead of tan 40, you put 0.8391 is equal to 30 over PQ. So when you cross multiply, you will go with 0.8391. Then 30 will go on its own, so that you will have PQ multiplied by 0.8391 is equal to 30. Divide both sides. Divide both sides by 0.91. Yes. So you will have PQ will be equal to 30 divided by 0.8391. So if you use your calculator to divide that, you will get your PQ
35.75.
735.
35.7525.
Yeah, we talked about the examiner asked you to approximate to
Round it up.
the examiner asked you to approximate to 2 decimal places. So with
Yes,
that,
sir.
our answer will be
0.75 meters.
to 2 decimal places. Let me sound a note of warning. Please, your dimension is in meters. If you look at the tower we are given is in meters. So your final answer, the dimension should also be in meter. And please,
Meter.
always forget to indicate your dimension. Then at the end of it, you can also come up and say that the line PQ is equal to 35.75 meters to 2 decimal places. And with that, we have successfully solved that question. Does it make sense to us?
Yes, sir.
Does anybody have any question? You have any question to
No,
ask?
sir.
Yes, sir.
All right. So I want to assume that we all understand this.
Yes.
Yes, sir.
All right. I will give us a small homework.
Okay.
Is it okay by us?
Yes,
Yes,
sir.
sir.
Okay. I want you to look at, there's something I want to call up. I want to call up something.
Okay.
Okay, something we can even do here, Seth. Can you see my screen?
Yes,
Yes.
sir.
You can see the image on my screen.
Yes,
Yes,
sir.
sir.
Okay, look at that image very properly, very well, and tell me
Yes,
how
sir.
many circles are in that image.
16.
Sorry?
16.
16 circles. Does anybody have any other option? Does anybody have any other option? All right. Let's clarify. The answer is 16. Now, how is it 16? Look at, can you guys see my cursor?
Yes, sir.
Look at this. Can we see one circle there?
Yes, sir.
That's one. Can you see another one here?
Yes, sir.
Can you see another one?
Yes.
Can you see another one?
Yes.
Yes.
So if you go on and all, this is another one, this is another one, this is another one, this is another one. So everything is 16 circles. So with that, we have come to the end of today's class. I want to assume that we have